2. All right, good afternoon, everyone. Thank you for your patience and thank you for joining us for this afternoon session on Yebo Physics. As you know, my name is James. I'm not gonna do much of the introductions now. I think I'm hearing some feedback here. Can you guys hear me?
Yes.
Okay, perfect. Thank you for the confirmation. Okay, so we're just gonna get on with today's tutorial on which is Tut3 questions 11 to 15. But these questions have been designed that we can cover on them. Firstly, after attempting questions that you guys might have. So if you have questions on Newton laws of motion and circular motion, this is the opportunity. You can bring them forward. We can try and look into those first. before we go on to the Tut practice questions. So does anyone have challenges with some questions which they were attempting, which you feel we can address? Anyone? Okay, seems you guys you have perfect understanding of the questions that you cover when you do the practice questions, which is okay. So I'll just share the screen from the Moodle, and we will look into the questions that follow. Okay, so our first question is question number 11 of Tut3, which is on the screen. Does anyone want to read it first so that at least we are in sync? Anyone who would want to read the question for us? You can't see the question.
It's we do see it.
Okay, can you read it for us, please? Okay, so it's a simple one. In the figure shown, the coefficient of kinetic friction between the block and the incline is 0.29. What is the magnitude of the acceleration of the suspended block as it falls? Disregard any pulley mass or friction in the pulley. So for this question, we are supposed to find the acceleration of this system. And so remember, we're looking at Newton's laws. You remember Newton's laws? Which of the Newton's laws are we going to apply here? And specifically, which part? So let's first analyze the system and try and figure out which of the laws do we use here? Or what are the three Newton's laws? What do they state? Maybe we start from there.
I think we're gonna use Newton's second law here.
Okay, what does it say?
Newton's second law states that the acceleration of an object is directly proportional to the net force and inversely proportional to the mass of an object.
Okay, all right, perfect. Thank you for that wonderful answer. So in this case, where is the acceleration and which mass are we going to be considering? Which mass are we to consider in this case?
It's 2m.
The 2m. Okay, so we have, remember what is shown here is an incline. So that mass, the force acting on that mass is basically gravity, but it is inclined at an angle as shown by that 30-degree angle on the slope. So now how do we get to that? Is that the only one that we use? Is that the only one that you use? That one is correct. We'll use it. What about the other laws? Are we not using them as well? What do you think?
It's Newton's first law and Newton's third law.
Yes. So we are using. Are we gonna use both the first law and the third law as well? Or do you think it's one of the two? What do you think it's both of them? And what
I
does
think we're
Newton's?
gonna use
Yes,
I think we're gonna use Newton's third law because
Newton's.
like
How and where? What does it state?
Newton's third law states that when object A exerts a force on object B exerts a object B exerts an
And
oppositely directed force
equal
with an
and
equal magnitude.
yes,
Yeah.
wonderful, good. So equal and opposite force. So equally directed force with equal magnitude. That's perfect. So the diagram here, let me just try and have the whole diagram show. This is the diagram. It's basically like this. So we have a 2m mass. I'm just gonna redraw it. Uh, okay, so we have an incline, we have a pulley. So why are we given this condition to say the string is massless and there is no friction at the pulley? What is the reason for that? What is the reason for that information? Any ideas? Is that information relevant in any way? So we don't want to include any other forces. Remember, if the string has mass, then it will lead to some other forces due to its weight taking playing a part in the forces that are being considered in this case. So we don't want to consider the mass of the string in that case. And as well as the friction at the pulley might also introduce frictional force, which we don't want to consider. So this is just to simplify the question. So if we have these forces now, how do we get this acceleration? Because the question requires us to find the acceleration of the block. What is the magnitude of the acceleration of the suspended block as it falls? So you have said that we use the third law. So the third law, there is tension here. What do I use here? Let me use this. So the tension force. Mm, can you please zoom the question? Okay. I think if I zoom it, we won't be able to see much, but let me try and see how much I can increase it. Something like this. How is it showing there? Okay. Okay, so this is the best I can do. I hope it's better if you are not able to see the question. Okay, better. Right. So now with this, it means that the acceleration in this case is a function of the net force. Remember, if we have the unbalanced force, that unbalanced force is basically a system, one that tells us we're not in equilibrium. So the net force is what accounts for the acceleration of a system. So if ever a system is moving and it doesn't have constant velocity, then that means that system is accelerating, and as a result, it also means it has a net force. So in this case, our system, we are told we need to find the acceleration, so it means the system basically is moving downwards. So we would have an equation for the vertical. So we can deal with the system vertically and probably for the incline separate. So for the vertical, we've got mg minus t equals to ma. So ultimately, if the system is to accelerate in that direction with an acceleration a, then that acceleration multiplied by the mass is the net force. So the net force is the difference between the weight and the tension in the string. Okay, that's number one. Then number two, we have the tension in the string because of Newton's third law. So this is a consequence of the second law anyway. So on the incline, the equation from the incline would mean we still have our tension. In which direction is the tension? In which direction is the tension?
Downwards.
It's downwards. Okay, that's interesting. Why do you say it's downwards?
On the incline side.
Yes.
I think it is downwards because that tension is pulling that
Good.
block M2M downwards.
Well said. Very good. So we've got a downward. Continue.
And like since we've taken that T on that block that is like that the one that is on
Suspended,
like
hanging.
yeah, like not that one that is inclined. So
yeah.
we've taken it as a negative and it's going up. So the one that is connected to 2M, I think it will be negative just because of it's going on an opposite object with that string that is going up.
Okay. All right. You started well. I like the very first part when you started with the tension going downwards. Yes, and it's the same magnitude. Do you agree? Same magnitude as the tension that's on the vertical side, right?
Yes.
Good. So because this is because of Newton's third law anyway, and this string, because it's also inextensible, it's not like elastic. So because it's inextensible, then it will have the same tension uniformly distributed throughout the same string. And also the fact that we don't have any frictional force at the pulley, we still continue with the same tension. Okay, so that's the other condition. So now if remember this tension, we have already assigned the A, the acceleration, which I've put with double arrows there. It is the same acceleration that will be on that part of the incline. And so the direction towards that acceleration is our positive. That's why you are, like you said, the tension is negative at the vertical side, but this tension at the incline is actually a positive. So because it's the same sense as the acceleration, so the equation will be that's tension plus there's a component of the force, a component of which color now? I'm running out of nice colors, but anyway, I'm gonna use red again because my force was in red already. So the force that goes into the incline will mean that this angle is also 30 degrees, right? So if you would take this incline back to the horizontal, this dotted line that I've put here would be the direction of the weight itself, right, on the surface. So it's going into the surface perpendicular. But then if you raise that incline at 30 degrees, this, which was initially going downwards in the direction of the weight, also tilts 30 degrees. So that's why that angle is 30 degrees there. And then the force component that is into the surface, the incline, will be mg, 2mg cos 30. So this helps us to identify our normal, which is supposed to be equal and opposite to the force that goes into the surface. So that also leads us to another force, which is perpendicular to the cos 30 component, and that's the mg sine 30 component. So we've got a force downwards, which is also 2 mg sine 30.
Okay.
Okay, so we add these two components, not the two components, this mg sine 30 component, which is down the incline because it is contributing to the acceleration. So it is added to our tension 2t plus 2 mg sine 30 minus. Now what do we subtract? What do we subtract? There should be a force in this direction. What is that force?
Kinetic friction.
It's yes, it's kinetic friction. And how do we find that kinetic friction?
We will use that coefficient of kinetic friction.
Yes. So the
Yeah, times normal
kinetic
force.
frictional force will be the coefficient times the normal.
Normal force.
And we said our normal has got a value of what? What is the value of the normal in terms of
Normal force is equal to a weight.
a weight component into the surface?
Yeah,
Yes.
normal force is equal to weight perpendicular. We cannot just say weight car.
It's equal to
Weight perpendicular, which is weight perpendicular, it's equal to mg
Nice.
cos theta.
Yes, so the weight perpendicular is the 2mg, the mass is 2m, so it's 2m times g cos theta. Thank you. Thank you, thank you, thank you, thank you. So we do that minus 2 mu, okay, mu times 2m g cos theta equals to 2ma. So we've got equation 1, we've got equation 2. We now have two equations there. What do we know? Since we need to find A, you are just given these masses in terms of, let's go back to the question. In the figure, the kinetic friction, we only know mu is 0.29. Theta is 30 degrees. Can we solve for A? Can we solve for A? So the given information from the question, mu is 0.29, theta is 30. Can we solve for A? Can we try and quickly do that? Show us your mathematical prowess. Tell us what you get.
So I don't know. Maybe I will ask this.
Yes, yes, you can
So
ask.
so if I'm looking greatly here, so that means that 2m, it's not like the value of a weight.
It's it means it is twice the value of the suspended mass. It is 2 times. So one is m, the other one is 2m. So it means by mass it is twice. If the first one is 1 kg, the other one is 2 kgs. So m is just an unknown value for the mass.
That means in order for us to get that acceleration, we're supposed to have two unknowns, which is that acceleration and the tension. So for now, if we have to use that simultaneous equation, we have to first get that mass so that we can substitute with it.
Yes. So how do we get that mass?
I'm still trying to look at it.
So because you have a relationship between them, it means generally it's an abstract condition where you have the suspended mass being half of the, what do you call it, of the mass on the incline. So whatever the case, they are related. You can just play around, fiddle around with that and see what it gives you. So meaning the simplest case would be to start by assuming m is equal to 1. If you have 1 kg there and 2 kg there, because that condition will still apply to whether you have 5 kgs and 10 kgs.
I think acceleration will be m1. I mean, the first m and the minus second m sine theta divided plus m, and then you multiply by the gravity.
Let's hear it again.
I said the acceleration will be open bracket, which is m, the first m minus the second m sine theta, and then you divide it by m1 plus m2, which is the second m, and then you close it, and then you multiply it by the gravitation.
Okay, so you said m1 minus the second m sine theta in your numerator.
Yes.
Am I right?
Yes.
Okay, let me write it here. A will be equal to your first m. So your first m is the suspended one, which is m. Then the second one is 2m.
Yes.
Sine theta.
Yes.
Close bracket.
Yes.
All over.
Yes.
What is
The first m
first m? Yes.
plus the second m.
Plus the second m.
Yes. Then you close it.
Oh, there's no angle there. Multiplied by the gravity.
Yes.
Like this. Okay. Do we all agree? Let's see what happens if since our theta there, sine theta will be sine 30. If give us a value, what will be the value if m is 1? What will be the value if m is 1?
Hmm.
Remember, sine theta is sine 30. I think sine 30 is half. So you have got m minus m at the top.
Yes.
Which gives you an acceleration of 0.
Yes. Okay.
So you made your A the subject from the expressions from equation 1 and equation 2.
Yes.
Okay. Yeah, let's hear others. Then we can see where you could have got it wrong. What do the others say?
Then if we take out the common factor of on that numerator and also in the denominator, like then the m will cancel, then we'll be left with 1 minus half m on the numerator.
Okay. So this is so if you take, doesn't m cancel out completely? So if you take m out there, you've got 1 minus 2 times sine 30, which is half, all over m 1 plus 2 multiplied by g. So this cancels to give 1. That's why I was saying it becomes 0. Did you all get this expression? That's the starting point for A. What is your expression for A from the two equations? What is your expression for A? Okay. So let me guide you a little.
Sorry, sir.
Yes, yes.
Sorry, sir.
Mm-hmm.
Can I? Okay. Let me share how I did it.
Okay.
I'm not sure.
Yeah, no problem. Let's hear it.
So you see equation 1, sir.
Mm-hmm.
The vertical in equation 2.
Mm-hmm.
What I did, I said equation 1
Yeah.
plus equation 2.
Wonderful.
I
Okay.
equated them both. Then, therefore, if you equate them both, the negative t and the positive t will cancel each other.
Nice
So
one.
which is you have two unknowns, m and a. Now, after canceling the both these, therefore you add the like terms from the one that has m with the m, then the other side, which is 2m times acceleration, and add it with the ma. So which is, if you see here, you will take out the common factor, sorry, which is m a, the common factor, which is ma, on the left, on your right side. Therefore, if you take the common factor of ma, you will divide with m both sides. So which is m will cancel on both sides. So you will be left with only acceleration. I'm not sure if
you make a lot of sense. I think yeah, unmute your mics and clap hands for him, please. Nice one, nice one, nice one. Okay, so that's as simple as it gets. Let's do the addition. Let's do the
Thank you.
addition of the two equations. So right now they look like this. So we're just gonna add the left-hand side with the left-hand side, the right-hand side with the right-hand side, right? So I'll start with, anyway, let me do the like terms first. So let me use a different color. So we're gonna have mg, right? mg, then we have minus t plus t, which is 0, so we don't need to write that. Then plus this part, 2 mg, sine theta is half, if you check with your calculator, minus 2 mu is 0.29. Sorry, I'm already putting the values there so that but at least we know what we're replacing, times m. Okay, g, I'm still gonna leave g, you know g is 9.8. Cos 30 is 0.8660, I think, which is root 3 over 2. So root 3 over 2. Am I right? I could be lying there. Cos 30. Yeah, it's root 3 over 2. Okay, that's for cos theta will be equal to the right side. What is the right side? The total, ma plus 2ma, 3ma, right? What do we see here? We've got m there. I like cancelling things out. That's my specialty. M, 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 M. We no longer have M, like I said, M will cancel out. So G is 9.8. We remain with 9.8 plus 2 times 1/2 gives us 1. Then we remain with another G plus another 9.8. Then minus 2 times 0.29. 2 times 0.29 multiplied by G, 9.8. Also multiplied by root 3 over 2. And the over 2 means these two can cancel. So we remain with that. Equals to 3a. And whatever is there, divide everything by 3. Everything by 3. We remain with an expression for a. So let's do the math there for that simple expression. Where is my calculator? Let's see what it gives us. So it gives us a number at the end of the day. So besides assuming whether m is 10 kg and 5 kg or 2m is 10 kg, m is 5 kg or whatever, it doesn't matter. So now I'm going to say 9.8 plus 9.8, open bracket, 9.8 plus. So when you evaluated this, what did you get for A? I'm sure you had already evaluated it for us. This divided by this. Where is the fraction like that? Oh, not the best. Okay, so 9.8 plus 9.8 minus what is subtracted there is 0.29 times 9.8. 0.29 times 9.8 multiplied by root 3 multiplied by the square root of 3, then everything divided by 3. So that bracket closes. We close the second bracket and we then divide by 3. 4.9. Did you get the same? What did you guys get? Is there anything like that? Wow, there's 4.9 at C. I like that. I hope it's even correct. What did you guys get? Because if you got something, it should be one of these choices. So where should I click? Maybe you got 5.2, then we can try the B. 0.86, okay, that's Tabelang 0.86. Which method did you use? We have to check. But anyway, it's none of the choices given. Or someone says same answer, that's Canva. Okay, let's see. Canva got the same. So, which means we should be in sync. Okay, so it's 4.9. That's how we get to the answer, guys. That's how we get to the answer. So who can summarize for us what we did? Who can summarize for us what we did here? Can someone summarize what we did, how we got to that answer? If you were following, let's hear it. Is it clear for everyone? Okay, since people were following, I can see some thumbs up. That's fine. We can continue to the next question then, which is the coefficient of kinetic friction between the surface and the larger block. So you can see that system there is 0.25. And the coefficient of kinetic friction between the surface and the smaller block is 0.4. If F is 22 newtons and M being 1 kg, in the figure, what is the magnitude of the acceleration of either block? So guide us as to how we deal with this situation. We've got two blocks. The two blocks are apparently being pushed by a force F. One is 3m, the other one is 2m. Then a force of 22 newtons applied on them. But we are told that the coefficient mu1 is 0.25. The larger block is 0.25. The smaller block is 0.4. Then mu2, 0.25. So that's the given information. M is 1 kg. So that makes it 3 kgs and 2 kg blocks. So find the acceleration of either block. So what is the acceleration of either block? How do we do with this one? Which of the Newton's laws should we look to?
Third.
Newton's second and third law.
Second and third. Okay, you chose the second and the third law. Okay, which is the same. One for acceleration and the net force, and the other for the reaction forces. Okay, so now how do we get to find the acceleration of either block? How do we get to the acceleration of either block?
I think that we must find the contact force first, then we'll be able to substitute to find the acceleration.
Okay, we need to find the contact force first. So this contact force will be, is it the same for both blocks? Is it gonna be the same for both
Yes,
blocks?
yes, but it will act in different directions.
Okay, all right. So the first one, where does it, where is this contact force acting from?
Mm. For the smaller block, it will act. The direction will be in the left.
From the surface? Is it from,
Oh no,
or from the big block from here?
so the contact force from the big, from the large
From the larger
block
block,
to the small,
okay.
yes,
So
to the smaller block.
from the larger block to the smaller block, it will act in this direction, to the left.
Left, yes,
All right. Then the one from the smaller block to the larger block is in the opposite direction.
yes.
Is it equal to it?
Say I don't know, Kengo.
Okay. All right. I like that. So we agreed we're gonna use Newton's third law, right? What is bringing the action? Which one is the action? So first, the 22, if these blocks are left like this, they will not exert forces upon each other. Do we agree? If they're just left without any external force, if F is not there, the blocks do not impose forces against each other. Is that true? Do you agree with me or not?
Yes, it's true.
It's true. If we don't have this force F in that direction, then these blocks are only experiencing a force under gravity, which is the weight downwards towards the surface, not against each other. There is no horizontal force there. But the moment we have the 22 Newton force, it introduces a force on the first block, which is to the right, and that force is is opposed by the frictional force on that block, right? Then there is also a force that goes further to also give or to also apply its effect on the bigger block, the 3 kg block. And the 3 kg block responds with an equal and opposite reaction. So you were right to say that we have a contact force here, but this contact force, one due to the 2 kg on the 3 kgs to the right, the one due to the 3 kg on the 2 kgs to the left. These forces should be equal and opposite, right? But then, whatever that force is at this point of contact, we still have a force which is due to the friction also opposing the big block. So we'll call the frictional force 1, FR1, and FR2. Those are the two forces that are opposing. Okay, so that's just an analysis of what's happening there. So now, what is the nature of this force? Let's call it FA, and this will be FB. So what is the magnitude of FA? In other words, are the blocks going to accelerate with different accelerations? Are the accelerations on the block going to be different?
No, sir.
We are going to have, because they're in contact, they should have the same acceleration, right? They should move together as a unit. Okay, so now we know that we can find our FR1, the frictional force on block 1 will be mu1 multiplied by the normal
No.
1, and FR2 will be equal to mu2 multiplied by the normal on block 2. So the normal there is basically an opposite of the weight, which is equivalent to 2g and 3g for N2. So we've got 0.4 multiplied by the mass 2 times 9.8, or let me just do this. Initially we have mg, so this will be m1 times g, and that means that's 0.4 multiplied by 2 times 9.8. What is the value of FR1? The frictional force.
7.84.
What? Come again? 7.84.
Oh, let me check again. I think it's 7.84. I'm not sure.
Okay, just cross check for us, please.
Okay, let me check. Yeah, it's 7.84.
Very good. 7.84. What's the unit?
It's newtons.
Newtons. It's a force. Good. Then the second one, mu2 is 0.25. N2 is the mass, 3m. Is it 3m? 3 kgs. 3 kgs multiplied by 9.8. What is that?
7.35.
7.35 newtons. Okay, very good. So now these are the two opposing forces. These are the two opposing forces. What do we do next?
I think we're gonna take. I think we're gonna take the first frictional force for 2 kg block. Then we apply it on the Fnet equal to MA formula to find the first acceleration. Therefore, we take the second frictional force, apply it again on the 3 kg block to find the acceleration again. Since you will find different accelerations, since that guy said we have different accelerations. I'm not sure.
Sorry, I missed some part there. You are saying for the first part we take the.
I was saying, sir, for the 2 kg block, we're gonna take its frictional force. Then we apply it on the Fnet formula is equal to ME. Fnet is equal to ME. Since we know the force applied, and then now we know the frictional force and the mass, so which is we can find acceleration.
Of
Is
the
it
first
correct,
block.
sir?
Okay, and that would mean, all right. So initially, that's why I asked the question, do we have different accelerations for the two blocks? And I'm sure we agreed that we have the same acceleration. So by virtue of us, what you're saying is very correct. But assuming we didn't have the second block, then what it would mean, the first block would have at least that acceleration is what would be expected to be on the first block. As the what is it, component of the motion of that first block. But now we have the second block. So what it means is the Fnet for this first block is actually applied onto the second block, and then that Fnet is now the applied force, which we subtract again with the friction FR2 to get a new Fnet, right? But that new Fnet is now the Fnet for the whole system. So in other words, in simply put, we are just taking the forward propagating force minus the total of the opposing frictional forces. Then we divide by the mass of the whole unit, because this system, if it is to move, it will move as a unit after overcoming friction. So can we do that part? We've already found what the opposing forces are. So let's find F net and get the acceleration for the system and not individually. So the question is quite trying to trick you there to say what is the magnitude of the acceleration of either block. So it is the same acceleration. It's not like it's different accelerations, because the way it says either block, it's like it tries to lure you into finding separate accelerations. But you can't say the first block is moving with an acceleration that's larger than that of the second block. It's not even moving with that acceleration, because there is another force which it experiences which opposes it due to the second block. Then once that one is overcome, they move together with the same acceleration. So let's find A. Given the information I've given you, can you tell me what A is? What did you get?
Sorry, sir.
Mm-hmm.
The thing that I've used, I said that F net is equal to MA, and
Yes.
on my F net, I've got two frictional forces.
F net equals to MA. I'll write it like this. Okay. And on your F net, you have what?
Two negative frictional forces.
And so you have F, the driving force, minus FR1 minus FR2, like this.
Yes.
All right.
Plus
Yes.
plus that applied force.
Plus the applied force, which
Yeah.
is I'll call it. Should I call it FA? F applied. Okay.
Yes.
All right.
Then then on my message, I've got two messes, but I add them then times with an acceleration.
Okay, so the mass is the total mass, which is the 2 kgs plus the 3 kgs, and this is
Yes.
multiplied by the acceleration. Very good.
Yeah, then I added those frictional force plus that applied force, and they give me 6,81.
Okay, so 22 minus 7.84 and minus 7.35 gives us, you said it gives you what?
It gave me 6,81.
6,81. Okay, so that should be equal to
Then
5A.
yes. Then I
And
divided by 5, then they gave me 1,36 meters per square.
1,36 meters per square second. Okay, wonderful. Wonderful. I think you are on point there. You should be on point. 1,36 is 1.4 to 1 decimal place, or two significant figures. And hence, it should be correct. Where is the answer? You have entered data outside normal sequence. Okay. Wow. What is this that's happening now? Anyway. All right. Number 10. 11, 12. Okay, so you are right. So that's the thing. So whoever said we are supposed to have the same acceleration, that is very correct. Also, if you look at the answers there, you can't find the acceleration of block A and the acceleration of block B separately. So you have to consider them as a system, as a single system. But then the only difference in this question is you have friction acting on the first. It gives you a first net force, which we called FA. FA acts on block B, and once block B starts moving with a certain acceleration, which is a result of a FA minus FR2, then all the blocks can now move. and that acceleration will be the same acceleration. So yeah, that's basically what we have. Our F net is the resultant acceleration after this F subtracts FR1 and FR2 to give us an F net at the output. And this F net is generally like the force acting on the whole system, the 5 kg mass. Okay. Then the next thing here is to look at question 13. The vector sum of 3 coplanar forces must be what? What is the vector sum of 3 coplanar forces? You are given conditions. Must it be 0? Must it be perpendicular to one of the 3? Must it be parallel to one of the 3? Must it be perpendicular to the plane? It may have any direction in the plane. What is the answer there?
Can you please show the question again, sir?
The vector sum, so the question says the vector sum of 3 coplanar forces must be A, 0, B, perpendicular to one of the forces, C, parallel to one of the 3, or perpendicular to the plane, or may have any direction in the plane. So it's not a quantitative question. You need to give your reasoning there. If you have 3 coplanar forces, what does coplanar forces mean? Forces acting in the same plane. So if 3 of them act in the same plane, the vector sum, must it be 0? Or can it be perpendicular to one of the 3 forces? Or parallel to one of the 3? Or perpendicular to the plane? Or have any direction in the plane?
It may have any direction in the plane.
Perfect. That's true. So it can only be 0. Can it really be 0? It can only be 0 if the forces make a closed triangle or the forces are balanced. So there's no net force. That's when it's 0. So if it was 3 coplanar balanced forces or forces in equilibrium, then that vector sum is 0. Then it can be perpendicular because the coplanar, it is out of the plane. It's not necessarily massive. It cannot be parallel. Okay, it can be parallel to. It's not like it must be parallel to one of the 3. That's not a must. It's not a condition. It can be at any direction, like E says. Then cannot be perpendicular because it's coplanar again. So E is the most appropriate answer there. E is the most appropriate. Okay, number 14. A 50 kg child riding a Ferris wheel, a radius 10 meters, travels in a vertical circle. The wheel completes 1 revolution every 10 seconds. What is the magnitude of the force on the child by the seat at the highest point on the circular path? Okay, so this is a question on circular motion. If I would have a Ferris wheel and a 50 kg child riding on the Ferris wheel of radius 10 meters. So if we would try to have a radius there, and that's 10 meters, and completes 1 revolution every 10 seconds. So the angular frequency is 2 pi radians for over 10 seconds. So that's 0.2 pi radians per second, right? That's the angular speed or angular frequency or angular velocity. Okay. Then what is the magnitude of the force on the child at the highest point? So we have got our seats.
Yeah.
There is a seat there, and we have a child seated on that seat. And then at the highest point, we have the weight acting there. And what else do we have? The reaction from the seat. And ultimately would need to have the centripetal force, which is the resultant force, or the net force is Fc. So Fc, the centripetal force there, is a resultant force, which is the force keeping the system in circular motion. So it will be that force keeping the system in circular motion. So in other words, our equation for this system is such that so it's such that we have the weight, which is downward, minus the reaction should be equal to F C. This is the net force. So it's like a net force. Centripetal force, in this case, the one that is giving acceleration towards the center, is actually a centripetal force, center seeking force, and it is the resultant. So this force is a resultant or net force. So what we want to find is the magnitude of the force on the child. The force on the child there will be, we want to find the reaction force. So now that we have omega, it means somehow this question gives us, what do we call this? From the omega, we should know A equals to. So this is omega squared over R, right? So it's mass times omega squared R. M omega squared R. So that's how we find the centripetal force. This is mass times G, the mass of the child, times G minus R, like that. So for us to find R, we make R the subject, mg minus m omega squared R equals to the reaction. And since the mass is 50 kgs, we multiply 50 by 9.8 minus 50 times omega squared, which is 0.2 pi squared, times the radius, which is 10, should be equal to R. This will be the force on the child. So let's see if that gives us any answer close to what we have on the choices there. Can you evaluate that? What do you get?
Sir, can you hear me?
Yes, I can hear you.
Mine is saying 292.
Yes, 292.6 newtons, which is 0.29 kilonewtons. So the answer there is in kilonewtons. It has been converted to kilonewtons by dividing that value by 1,000. So the 0.29 should be the correct answer if we did the calculation right. So that's
I have a
basically,
question, sir.
yes, bring it on.
Yes, so my question is, if the child was like at any other point that is not the highest point, would the force be any different?
Yes, it will be different. So if you consider the child at the bottom of the Ferris wheel, then you've got the reaction being the centripetal force. So it changes. From the bottom, you would have the reaction minus the weight being equal to Fc. It changes. So it means the reaction there will be Fc plus W. That's where in this case, what can you say? The reaction is actually mg plus Fc plus m omega squared R, because this is R equals to mg plus m omega squared R. So you can see that this is the least of the reaction. That's why you feel weightless at the top. You can, when you pass through over a hump, let's say at a high speed, right? You actually feel that weightlessness as the car suspends you in the air, and then you start coming down. So this is where you have the least reaction. But when you're at the bottom, that's where you experience the maximum reaction, because your reaction is mg plus the centripetal force. So it changes, which means elsewhere between the top and the bottom, it takes the values in between. The top is the minimum, the bottom is the maximum. Everywhere else, it's in between those two values. Are you answered?
Yes, I'm answered. Thank you, sir.
Perfect. Great question there. A rock. Okay, the next one, question 15, our last one for the day. A rock attached to a string swings in a vertical circle. Which free body diagram could correctly describe the force or forces on the rock when it is at the lowest point? So there's A there. We want the free body diagram of the rock swinging from a string, and what happens when it is at its lowest point, which forces act on it from the lowest point. So the first one is just showing no labeled force there, but it shows, so it's a free body diagram. We want the main forces and not the resultant. So there is tension on B and weight downwards. C, tension alone. D, tension upwards and the normal downwards. And E, tension upwards, weight downwards, and a force to the right. So which of the different force free body diagrams is correct?
B.
I didn't get that.
B.
B. B, A, what else?
B.
Did I hear D? C?
B.
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 E.
Okay, so B is echoing more and more of B. Yes, B is the correct one. Let's check.
Yes.
B should be the correct one. Now, finish attempt, yes. So the correct answer is B, yes. The correct answer is tension upward and weight downwards. E, we can't have any force. There's no way we can explain that force there. And we don't have a normal from the string. There's no normal. It's actually a weight which should be there. That's why D is wrong. T is not a complete force ball diagram. For C, this one we have agreed is correct because it gives us all forces acting on the rock when it's at this minimum position. Tension in the string upward and the weight downward. So this shows it's not even the resultant. The resultant should be in the direction of the tension because the stone still goes up afterward and it keeps its circular motion. So the resultant should be upward as the centripetal force. Okay, so that's about it, guys. Thank you for your participation and for joining us for this afternoon. We'll meet again in the coming weeks. If you have questions, I'm sure you'll be having your tests coming soon. So please read more, and once you find challenges with any of the questions that you come across as you practice, please bring them over. Arnold and Lucian will also be coming on other days to try and assist you. So otherwise, are there any questions? Okay, thank you, guys. It was wonderful having you on the platform. Let's meet again in the coming week and have a pleasant weekend.
Zamo, yini kanje le nkomo eninanga? Yesu. Yini be? Sesha kodwa le. Igama lezivule ibizwa ngayo. Yini inkunzi? Hayi, inkunzi.